The next part of our lecture is smart grid overview. जब हम बात करते हैं when we talk about the definition of smart grid, we come to know about the 4 R's. Basically, we come to know about the 4 R's. That R is resilient, reliable, robust, and reconfigurable. Whenever we talk about resilient, what we mean about resilient is that something that can recover very quickly, just like spring. If we press the spring, it will come back to its original position. That is our resilient. Reliable. It gives same results in all trials. For example, when we perform tossing a coin, it will give me probability 0.5, like it will be head or it will be tail. So it will not give same results on all trials. So this is not reliable. Something that is robust. Robust means something that is strong. Reconfigurable means something which we can reconfigure to get the optimum results of that. Okay, so if I talk about our smart grid is our advanced power system network. Okay, so what is basically a smart grid is an advanced power system network which provides a two-way digital as well as electrical power flow. This is one of the main thing of our smart grid, that it provides a two-way digital as well as electrical power flow capabilities. Also, it is a self-healing system which is adaptive, resilient, and sustainable. It is foresight for prediction under different uncertainties. It is interoperability like present and future standard. Also, it is cyber secured against malicious attack. If I talk about definitions, actually this definition was given by James Momo, and there are various definitions given by various organizations. One of such definitions given by National Institute of Standard and Technology, NIST USA, is that they told that smart grid is something that provide a bidirectional flow of energy. If I spell that definition, it says that a modernized grid that enables bidirectional flow of energy and uses two-way communication and control capability. What it told, it provides two-way communication and control capability plus control capability, right? That will lead to an array of a new functionality and application that is given by NIST USA. Whereas when I talk about IEEE, it says that a smart grid is a system of systems where each functional domains consist of 3 layers. That 3 layers are the power and energy layer, communication layer, and IT layer. So communication and IT layer makes power system smarter, we already know. But what was missing in definition of IEEE was they missed out the distributed intelligence term. Now, if I talk about need for smart grid, we know that geographical area wise, we are getting enhanced. So due to larger distance between the major load centers and conventional centers, we need something that is much more smarter than already existing power systems. Also, there is large number of interconnections due to political, economical, environmental, reliability, and sustainability issues. That is increasing. Basically, area is increasing, interconnections are increasing. We know that due to the rapid increase in the population and standard of living of the people, the development of townships, new development of buildings, the rapid global demand for the electricity is increasing with the time. Also, the power system components operate near design limits. So we know that whenever the demand for electricity is getting enhanced and we are having the limited resource to send that our energy, our electricity from that system, so what will happen is that we will operate that to the designed limits, near to design limits. So what will happen? It will, at some point or other, it will get malfunctions. It will get broken at some point of the time. So what we need, our smarter system that can even detect and just tell me and give me warnings. Also, high penetration of renewable energy. Now what happened here is now people are getting more used to the renewable energy installation in our distribution system. So what is happening here is due to high penetration of DERs at our distribution system, need for smart grid has been increased. Also, what we need is a real-time monitoring, and for that we need a strict regulation. So in our coming years in India, we will get our real-time energy information, and we will be allowed to trade energy in the electricity market in the near real time, just like we are trading the stock market. That's why there is a need for a smart grid system. After that, the next part of our system is smart grid network. First of all, why we need our smart grid network? Smart grid network is a flexible, secure and communication that is full of advanced controls. Right. So what is our smart grid network? So we know that the transformed power system network is a utility are poised to move beyond the traditional power system to the highly flexible, secure and the green power system. We know that earlier what we had was something called generation, transmission and distribution. But today what we have is our generation and our transmission. When we talk about a transmission system, it has combined our solar part and wind part in our transmission system. And distribution system is not only a distribution system, it comprises of energy storage part, also the distribution network which is connected with our industries, commercial, residential. It comprises of rooftop PV, wind, and one of the main thing was microgrid. This is what has made our smart grid system. Earlier what happened was there was only a power flow with what is shown by the black arrow. But nowadays what happened was ICT is also present, which is shown by the red arrow. Everything is connected to each other with ICT network. Next thing was smart grid network. When we talk about some network, like this is our building, so this will comprise of what? Different types of customers, different types of loads, different types of equipments and so on. So if I talk about smart grid network, it will comprise of customer devices that receives the price signal, energy providers like central generators, renewable energy system, energy users, single home building loads that are controlled, distribution system, it provides reliable service, transmission part to monitor and adjust the resource, network operators receive communication from the sensors and send data prices to all the participants. Then comes our smart grid building blocks. Whenever we talk about building blocks, okay, what is basically building blocks? It comprises of automation part. Which automation? A distributed and substation automation. It provides advanced metering and communication capability, synchrophase measurements, wide area monitoring and control, distributed intelligence, IT evaluation of IoT, cloud and cloud computing. The next term or next part which we come through is what is the basic difference between the conventional and our smart grid. So basically when we talk about our difference in conventional smart grid part, first and the foremost difference is in our architecture. When we talk about our previous architecture of a home and the current architecture of home, we can see that there are different architectures. In the previous case, we were using our architecture which was made of mud, and today we are using that is made of the cement buildings. In the similar fashion, earlier architecture was a vertical structure and today it is unbundled and distributed structure, where we are having DRs, wind and all, which I have explained in the above slide. EVs, microgrid and everything is unbundled. Second thing was customer participation. We know that in earlier case we were not having any customer participation. They were just given the bill, they need to pay that. But today each and every customer is informed and they are participative in our energy trading. So second part is our customer participation. Third part is our generation and storage capabilities. We know that in the previous case there was only central generator, right? In the previous case there was central generator, but today we are having DRs with plug and play features that provides an excellent features for the smart grid. In previous case the power quality was focused on outage, but today power quality is one of the priority also. Then comes our asset optimization. In the previous case there was no asset optimization, or we can say a little data integration, right? But today we play with our data and we obtain our predictive asset management with asset optimization. There's one more thing what comes about is new product and services. So that is limited or poor customer focus, but today better market and services are available for the customers. Then comes our self-healing capability. In previous case there was no self-healing, but today self-healing automatic predictive fault analysis is present. Then comes the cyber attack. In the previous case, vulnerable to cyber attack it was. Anyone can attack our system. But today, when smart grid was came into picture, it is becoming resilient to cyber attacks. New algorithm is being developed to enhance how we can enhance the cyber security of our system. Then comes the disaster management. If there was some disaster at particular point, so we were not able to respond that quickly, but today there is a quick and proactive response to that disaster. Event analysis. So what we talk about event, it is a slow and tedious event analysis process, but now there is a smart and forecasting analysis also used for that. Communication, it was one way and today it's a two-way communication. Predictive analysis, and when you talk about predictive, non-predictive process and apps, and today it's a predictive analysis. Intelligence, there was limited intelligence, but today we know that my system is completely intelligent as is integrate and process critical information. Efficiency, it was poor efficiency, but today when we talk about it's an efficiency focused system. Now comes our smart grid domains. When we talk about smart grid domains, it consists of a generation part, it consists of transmission part, distribution part, customer participation, operation, market and service provider. The generation part will consist of our renewable energy, coal-based generation. Transmission part will mainly focus on the power transfer from the generation to the distribution. Distribution part, we already know that we are having our distribution part. Then the customer participation. There are three types of customers. We already know: residential customer and commercial and industrial. They all focus on the demand response. Operator, it's a network operator for recording and analysis and for controlling. Market for purchase, for pricing information. Service provider for retail and aggregator, communicate with market and operating customer. It basically provides a billing, forecasting, home energy management, installation, commissioning and account management. Regulatory challenge, convenience to go for the smart grid, right? So when we talk about our smart grid, regulatory challenges, so there are different types of regulatory challenges. We know that many utilities are doing with the current practice. So what happens here is, if we are doing something good and if you want to change that habit, it is very difficult. That is one of the regulatory challenge. Also energy efficiency. So what happened here is, energy efficiency is one of the benchmark of the smart grid, right? This does not necessarily lead to the economic efficiency, but at least for the short term. So if we see for the short term, it will not be as much efficient, but for the long term, it is highly beneficial. Also, for the obvious reasons, smart grid technologies are implemented in phases. So when we talk, if we implement some part of a project in phases, we will not see an overall progress in that part. But once that project is completed, we will see advantage of utilizing it in the complete part. Also, policies to the reward and incentive investment in smart grid need to be formulated, because if government is planning to invest in DRs or in solar PV integration in our system, because of its higher cost, it will not get implemented. So what happened here is, the government need to put one step forward to implement some reward and incentive investment in the smart grid. Mechanism need to be worked out to involve various stakeholders. Now government need to bring some stakeholders to promote the technologies, to promote the features of demand response, which people are lacking. Also encouraging system operators and utilities to play more active role in addressing the future economic, technical and social challenges. So also the data from the meters, PMUs and IDs, RTUs need to be analyzed properly. Also when we talk about the data protection issues, that is one of the main issue that need to be handled in the challenge case. Data protection, integration of various technologies from various vendors. This is one of the main drawback of that. For example, I'm using one pen of company A. Next day, I'll get the manufacturer B of that same company. So there is a different shape of that pen which I will adopt to use. And now if I'll use the pen of company B, there is slightly difficulty if I try to use the company B pen. So that is a point when we try to integrate various technologies or equipments of different vendors in our power system network. Next thing comes our smart grid agencies. We know that I already discussed there are various agencies like IEEE, IEC, NIST, SIGRI, UCLUG, APRI, NREL, ISA, NERC, various smart grid agencies in the globe. When we talk about smart grid in India, there are different agencies like Indian Smart Grid Forum, Indian Smart Grid Task Force, National Smart Grid Mission, which was established by Government of India in 2016. Central Power Research Institute, established in 1960. Also, many utilities have started individual activities at different levels. Several smart grid pilot projects are also funded by Ministry of Power. One of such pilot projects is in one of the IITs, that is IIT Kanpur. Next part is our smart grid layered architecture. Okay, so whenever we talk about smart grid layered architecture, it will consist of smart grid from the bottom. If we see, right, from bottom, if we see bottom, we are having our component layer. When we talk about our component layer, we are having here generation, transmission, distribution, DRs, customer premises. There are different domains in customer component layer. After that, there will be some communication layer, information layer, function layer, and on the top we will have our business layer for doing some business activity. So whenever we talk about different types of layers, we are having communication layer, which is used for just like HAN, house area network, for customer, neighborhood area network for distribution system, wide area network for transmission system. When we talk about our information layer is like our IT OT system. Like IT, we are having service bus, OT, we are having one service bus, real time service bus. So that is IT OT convergence. It provides our information layer. Then comes our smart grid architecture model. We know that we already studied some part of smart grid where we are having market, operations, service providers, bulk generation, transmission, distribution, and customer part. I already discussed about the communication layer, like there are various types of communications that are available in our literature. It consists of external, enterprise, wide area network, neighborhood area network, house area network. Then comes our smart grid information layer. I already discussed about the information layer here. It says that it provides IT and OT convergence, in which in the between we are having SCADA, network management, outage management, and historian network planning. Here are on the top, here are some legacy applications, intelligent field devices. Here we are having CIS, ERP, EAM, advanced metering infrastructure, and market. Then comes our SOA model. In SOA model, when we talk about, we are having two main things, that is SOA adapter and high speed adapter. SOA adapter is basically used to convert like it is connected to enterprise service bus. I will check whether I have defined. No, I have not defined. So I'll define it here. So SOA adapter, if we talk about, let's this my smart grid enterprise service bus. Okay, enterprise service bus, and my SOA adapter is connected here. Now there are some just like it is understanding some language C. So and it is written in Python. So Python will be converted to C using the SOA adapter, and then it will be sent to our ESB, enterprise service bus. In the similar fashion, we are having our high speed service bus adapter, basically to convert one proprietary language to the other that it can understand. That is use of SOA adapter and high speed bus adapter. Smart grid model for information exchange we are having, in which IC 62357 is used, which is used for application to application or business to business communication. Now comes smart grid function and business layer. So smart grid function and business layer, we are having advanced EMS architecture, business layer and function layer. So it is having advanced EMS architectures in which there are various types of protocols are used, like DNP 3.0, 61850, and the data which is sent from PMU is sent through IEEE C37.118 and so on.